Hello everyone, this is Team Solid. Hope you enjoyed our last YouTube video pitch. Today, we'll be introducing how we build each part in SolidWorks. This is the top part of our blood pressure sensor. To create this part, we first create a sketch. As you may have noticed, in the sketch, the main curve is actually made of 3 parts. The reason why we include a top part, we do it as a flat surface instead of a curve, is that we want to attach springs to the surface and also create a lot of holes here, so a flat surface will make it easier instead of a curved surface. We also have a lot of dimensions and geometric constraints to make our draft fully defined. We also used mirror entities so that it makes our process of creating sketch easier and faster. The dimensions are designed to fit a normal adult wrist, as you may see, and all our dimensions are in millimeters. After we finish with creating sketch, we do a box extrude. So this gives our main shape of this part. And then we do an extrude cut. But prior to that, we need to create another sketch. So we choose the top flat surface and draw out 5 holes. The middle one will fit our butterfly screw. So I make the hole a little bit greater than 6.35 because I want it to be a loose fit for the screws to actually spring and move. The other parts I create as a tight fit. So I set the diameter exactly the same size as the screws that we purchased, which is 2 millimeters in diameter. And then we just use the extrude cut feature to cut the holes. Similarly, we use the same feature to create our side holes. After that, we do the fillet. The reason why we're doing fillet is because we want to make our device better fit the wrist, instead of having our protruding part or sharp edges hurt the wrist. And finally, we use the thread feature. This feature allows you to create threads inside of a hole automatically. So here you can choose the edges, the depth of the thread, and the size of the thread. I set all index here to comply with the screws that we are purchasing. So all these parts should fit perfectly. I do want to mention that because this thread is pretty hard to print out in a 3D printing device, so we end up just printing out the hole without the thread and use our purchased screw to just thread the parts because the plastic is pretty soft. And this is our first part. This is the bottom part of our ECG wrist frame. This part is very similar to the part that I just introduced. So first we still create a sketch. The only difference is that this time we just do a full curved surface instead of inserting another flat surface in between, because this is the bottom part and we don't have to insert any screws or holes on the surface. So this makes things much easier. And the dimensions are set to fit with the upper part. After the sketch, we do box extrude. And then we just fillet our edges. And likely, we also do extrude cut for our side holes. After that, we use the thread feature again. And we set the index to be exactly the same as what I did in our last part. And then this part is finished. It's quite easy. This is the top part of our SpO2 sensor. As you may have noticed, the overall shape of this part is pretty much the same as the first part that I introduced. This is because I started using exactly the same sketch as I did in the first part. After we create the sketch, we just do box extrude, and that gives its main shape. And then I do 2 cut extrude. This is because I want to enclose a photosensor chip here. The size of the dent is based on the size of the actual photosensor chip. And after the second cut extrude, I create a slot here. So through the slot, we can connect some wires to the photosensor chip. And then the other end of the wire can be connected to Arduino or other signal analyzing device to analyze the signal that we get. Next, we create these 2 holes using hole wizard. The reason why I'm using hole wizard but not extrude cut is because these 2 holes are on a curved surface and it's not so convenient to create holes on a curved surface using extrude cut. But hole wizard can do that. Let's take a look. So in Hole Wizard, you can choose different size holes and also choose the positions freely. So I choose to put the holes here using some geometric constraints. So it's pretty easy to define the position of holes using Hole Wizard. And then I just do some simple steps like doing fillet, and also use extrude cut to create the holes on the side of that. This is the metal sheet beneath the SpO2 sensor. In a normal ECG clamp, the metal sheet is connected to the electrode, and its main function is to conduct the electrical signal from the blood vessel. But in our design, this metal sheet has another function, that is to fix the photosensor chip. So first I create a sketch, and this sketch has exactly the same shape as the bottom surface of the top part, so that the metal sheet fits well with the top part. Actually, I just copy and paste the whole curve here and use reference geometry to fully define the sketch. I noticed that the whole curve is too long for a metal sheet, so I also did trim entities to trim off some material here. So now we finish with sketching, and we do box extrude. Since it is a photosensor, we still need to create a hole to let the red light and IR light pass through so that the photosensor can function. That's the reason why I create another cut extrude here to create this cleared hole. Also, I still need to create two holes here to allow the screws to pass to lock the whole metal sheet and the top part. So I use hole wizard again to make the position of the holes align with the top part. I set exactly the same dimension as the bottom face of the top part so that the position of the holes align with each other. And I create the size of the hole to be a little bit bigger than the size of the hole on the top part. This is because I'm going to screw the screw on beneath, and the screw is a flat head, so I want a hole that can make the screw head half in, therefore there's less screw head protruding out, but the hole is still able to fit the screw so that the screw can lock the photosensor here. And at last, I create the fillet, because this part comes in direct contact with your wrist, so you don't want sharp edges. This is the metal sheet that encloses the top part of the blood pressure sensor. This part is connected to 4 tiny springs and will move up and down to insert and release pressure on your wrist. To create this part, we first create a sketch. And this sketch is actually the same as what we did for the last metal sheet. We just copy and paste the shape, and then do 3 entities, and I also did offset entities so that I can change the thickness of the metal sheet to 1.5 millimeters. After that, we do our first extrude, box extrude, and then we did a series of different box extrudes. For these extrudes, we extrude the part in both directions, like this. And likewise, we create our second box extrude. And then we did some extrude cuts to create those tiny dents on the surface. This is to guide the spring to its correct position. And so like this one. And then we fillet the edges. Finally, I did a little cut extrude here because this part is supposed to be loose fit and is actually the moving part, so I want the actual width to be wider than the width of the top part so it can glide through. This is the butterfly screw on top of the blood pressure sensor. We are actually purchasing this part online, but we also created one in SolidWorks. To do this part, first we do a box extrude. This creates a cylinder like this. And then we need to do another box extrude to create the wings. So we created a sketch like this. The shape does not really matter, it's just the shape of the wing. And then we did a mid-plane extrusion. After that, we need to create a plane here. The plane should be above the height that you plan to start threading. So now you have the plane defined. The next step would be an extrude cut. The purpose of this step is to create a surface that you need to use for the thread feature. So you just extrude cut from the bottom face to the plane you have just defined. Finally, you just use the thread feature to create the thread. Actually, we have other ways to create the thread, but I think if you are just doing a standard thread, using the thread feature is the easiest way. Or alternatively, you can also do it manually. You can set curves, use helix and spiral, and you then define the shape of the thread. Then you use swift cut or swift boss to create the thread. That way also works.